Yo, Mr. Boyle here. And this next section, this is 2.1. This is Check Your Understanding Part C. And this one deals directly with something called your Z-score. So in this class, they did the first steps of something called Where Do I Stand activity, which just dealt with how tall each person was in the class. So this is a dot plot. So for instance, 60 inches tall, there was one person, there was two that were at 62, looks like four at 63. The tallest person or two people were at 75 inches. Underneath here is the computer output. So there were 25. N is the number of people in the sample. So there were 25. X bar is your sample mean, which is 67. S of X is 4.29. That is your sample standard deviation. The minimum, so this is your 5 num sum, minimum, Q1, median, Q3, and your max. So Lynette, she is a student and she is 65 inches tall. So she is this dot right here. Find an interpreter Z-score. The equation for the Z-score is your value minus the mean divided by standard deviation. So it's a straightforward mathematical. You're just going to put it in. So her 65 minus 67, which again is right here, that's your mean average over 4.2, which is the sample standard deviation. I get -2 on the top, straight, just simple mathematics, and I get -0.4662. What does this mean? So Z equals -4.66. Lynette's height is 0.466 standard deviations below the mean height of the class, which makes sense. She is shorter than the average in this class by 0.4662. So she's not a full 4 inches, 4.2 inches less. She's only a little bit, like maybe close to half of that. If we do the same thing with Brent, Brent is tall. He's 74 inches tall. So he is this dot right here. Same steps. So still the mean is 67. Standard deviation for the sample was 4.29. I get 7 on the top divided by 4.29, which equals 1.631. That means that Brent's height is 1.63 standard deviations above the mean height of the class. The big thing I want to point out is be very careful with your calculator. Remember that order of operations, if you just type this in without parentheses around the top, it will divide the 67 by 4.2, then subtract it from 65, and you'll get an incorrect answer. So be really conscious of either figure out the top, like in your head, like, oh, it's -2, or in this example, it's 7, and then do your division. The third part of this is, hey, Brent's a member of his school's basketball team. So the mean height of those players is 76 inches. So they're taller than what the average was in his class. Brent's height translates to a Z-score of -0.85 in the team's height distribution. What's the standard deviation? And this is the standard deviation symbol of the team members' heights. So again, it's the same little equation that we're using. His value minus the mean over standard deviation. We know by him having a negative, that means that he is shorter than the average, which makes sense. He's 74 inches from the previous question, minus 76, which they gave us as the average. This time, though, they gave us the Z value, all right, or the Z score. So we'll put -0.85 out here. So if you simplify, it looks like this. It's a little bit of algebra to manipulate and move it around, but you'll find out that your standard deviation for this sample is 2.35. That's a quick synopsis of Z-score. This is Mr. Boyle, and I'm out.